Hi, welcome to this video on my Arduino Mega2560 with electronics and fischertechnik motors. Last time I managed to get this motor and switch working via the pot meter and input, then output to this LED, and when the switch is being touched by the chain or by the pin in the chain, then this LED will flash. So let me show you. So let me show the rest as well. That motor runs, that motor runs, this motor runs, and if you have seen the previous episodes, you know the history of all those motors. And in this case, the pin in this gear, moved by the chain, touches and then flashes this LED. The reason behind this all is digital input instead of all the other stuff which is being controlled by analog output and some pulse width modulation. Now the question is, the solution last time was both 3 wires here and a replacement of values, comparing values in the if statements, because somehow I need in if statement comparing to this high value instead of 1 and a low value instead of 0. And with this I'm going to try to use this LED as digital output, so they are going to flash exactly the opposite way. So let's go to the source code and see how that works out.
When looking at the code, we see that pin mode 7 is output, which leads to the LED. Pin mode 12 stays the same, and what we need to do is finding out how the green LED is being controlled. And we don't need to use output value 2 right now, although it is being used for the green square LED, but it is analog and we want to go digital. So we look at the pin by which it is controlled, which happens to be pin 9 or output 9, which is here, this line. So what we need to do is commenting this out and telling the software that we need pin mode 9 as an output. And with pin mode we make it digital. So going to the if statement, when the sensor value dig is high, then we need to make digital write 9 low. We want to do that not after another but at the same time. So this is 1, and then digital write 9 to be low. And it should be as simple as that. Now of course pin 9 is no longer necessary, so I comment this out, and that should actually be enough. So let's upload it and see what happens. It compiles, uploads, and that should be it. What we also can do is, no, we can't do that, because what I wanted to do is see in the serial monitor to see what's going to is what's happening, but I didn't write anything to the serial monitor, so I can't show you. Anyway, let's see on the board what is happening.
So now we have uploaded the code, and what do we notice? This is going alright. However, this doesn't do a thing, which may be caused by an improperly seated LED. So let's push it further into its socket. But still then it doesn't do a thing. So let's check the rest of the connection. And this one is going there. That must be 9, and I just pull it from its socket. And it's doing absolutely nothing. Now I could measure the voltage, but let me first put the potmeter up to its highest, and now what you can see is that the yellow LED isn't doing anything. So I'm putting it there, and now to my surprise the yellow LED isn't doing anything anymore. Now it is. Is that the case for the green LED as well? I can't tell. Oh, I notice here a problem, because it is not, I misread it. Let's see, this is 8 and this is 7. It's not the white, it's the red wire I should follow. but then again that functions properly. So this is a kind of a mystery, and let's try to solve it. Reseating a wire. I do remember that this one always had a problem with burning, so that may be it. So let's just put in another LED. And then this one should do it. Or the other way around. And it's not. So this is something I should try out. And it should be like this. And I have a wiring problem. Now they should be seated. This one is still working. Let me put this one around at the same time. It's quite hard to do. Because they are unequal of length. Never easy. That is one. That is two. No, it's not seated. Okay, let's do this off cam. Now there was a little bit of a problem, because you may have noticed that I put the green LED to twice low, both in the if high and in the if low. I corrected that, but it still doesn't work. So it's time to start measuring with the multimeter you've seen before. So what I need to do is use positive somewhere. Let's use it from here, and then measure and it turns out for the meter that I need to put it the other way around. So let's measure this and the resistor, and that shows that it actually does work quite well. So with the multimeter at hand, I'm going to measure, and I will do that with the positive here. And I hope I will not interrupt the view on the multimeter, so I put one here. Then I will measure on this resistance with the resistor, and then you can see that now I reverse the probes and I do that again, that you can very clearly see that the pulse is there. And that is all I needed to know. So another point is that when I put the green LED right next to see, now it does. And now you can see that it actually does work. It is some contact after all. And it is completely reversed compared to the yellow LED. So this proves that it is a contact after all. So I need to adjust the contacts of the green LED. But this way you can check that the circuit is fine. And this opens, of course, some possibilities on the rest, digital versus analog. But I'm glad that code proves to work, although the hardware isn't always cooperating nicely.
So now the green LED has shown to work. I'm going to go back to one other conversion or transition from analog to digital. Some time ago I had 3 LEDs in a row, so I put a red LED right next to the green one, and that one is being controlled by output 5. So I'm going to disable the analog output . Let me do it in sequence. 5 output, so now it's digital. And now is the question, how shall I do this? And it is quite easy to do actually. So I think I'm going to make it blink. So I do 5 high. And then a short delay. Let me make a 500 delay, and then a digital write 5 low. So this way it is supposed to go blinking quite fast. And only when the signal is high. So let's see how this works out. Error compiling. Why is the error compiling? Analog output. See, I forgot that. Yes, I need to do this. Very, very nice. The only point is now that the red LED isn't doing anything at all. So let me check the wires a bit. It is 5 and no, there is nothing that seemingly works for the red LED. So this is quite a bummer. Let me see if the red LED is working anyway. So I will put it against the working resistor. And it shows nothing at all. So it is probably so that the red LED, which if I recall correctly from other experiments, that it burns very faintly. So that may be the cause of it. So let me put another green LED in it, and let me just show on screen. That's much better. So this red LED is supposed to work, and if you put it you see that these LEDs are working exactly the opposite way. This red LED doesn't work at all. And if I put this in between here and next to the green LED, it should behave exactly the same. Which it clearly does not. So I'm taking another green LED, putting it in here, and hopefully, yes,
However, it is not entirely what I expect, because it's way too long burning. This should flash for a very short time. So let me get back to the code. And upload. Is this visible? Hardly. Shorter yet. Back to 125. Uploading. And then I realized that it is in the same thing, so it is, let me do it another way. I put it in, is this even possible what I want like that? Because this delay is influencing the rest as well. And that is obviously not entirely the objective. So let me for now remove the delay. And I'll put a digital write 5 low with the others. And compile and upload. Now this one should keep working. And I think yeah, the whole sequence is back to what as it was, because the delay was influencing. So now it is actually these two that are doing the same, and this one is doing the opposite. And I think that's a nice result. So for now I have non-functioning red LED, a non-functioning green LED, a correct green, and this unfortunately limits the number of experiments what I can do with LEDs, although I have some spares. So who knows what's in store yet. So for now, thank you for watching, and as you can see and can know by my experiments, not everything goes as planned and intended. Thank you for watching, and to be continued.